Okay, next one here, 5.3. So this is now we're taking a look at 3D objects. Now this one is going to be something I'm going to recommend you actually split this up into two of them, into two washes. It's the probably the beefiest of all the sections here in Module 5. So this is when we start looking at what we call an isometric drawn. So this is a way that you can turn like a 3D figure into like how you can write that into like a 2D plane. If any of you seen like Interstellar, for example, you would have seen like, this is a tesseract, but we can't comprehend it, but this is what it looks like. So an isometric drawn is a way to kind of do some of that. So to give you an idea here, like, what is an isometric drawn here? It's something like this. I've taken a 3D object and I've made it visible on a 2D space. That's what this is here. Um, Now, one thing to note is that these are drawn to scale. So just like how in a graph, if I say this is 5, this is 10, this is 15, it goes up at the same rate. It's the same thing. It's drawn to a scale. Um, Lines that are parallel in real life are parallel in the drawn. It is a hyper accurate drawing. Okay, so detail is critical. Lines measured Lines are measured 30 degrees from the horizontal are used to show the width and the height. What do you mean? Like what? What does that mean? Again, looking at this thing here, um, if you can see where my mouse is right now, that's a 30-degree angle. That is showing the width. Okay, going up and down adds height, and then you add depth by going on a 30-degree angle here, and it can go both ways. So you actually get a specific type of paper for this called isometric paper. This is what I talked about earlier in 5.1. You don't have a lot of this paper. You just don't. You don't have any. Sorry, you don't have any of this paper. If you have your workbook and nothing else, you're welcome to print some of this. You can just Google isometric dot paper and you can print some out. You can't loose leaf this, so use a pencil and draw lightly. Okay. So I want to use my isometric dot paper to draw a cube with sides that are 3 units long. In this case here, all I can really do is show this to you, right? And you have I'm actually going to use these solutions here because you don't have a lot of this isometric dot paper here, right? But you start at the bottom corner that's closest to you. Very key point. I want you to literally like box that. That's where we always start here. And you want to draw it at a point that will allow space for your diagram. You need to plan before you draw. What's the saying? Measure twice, cut once. It's the same thing here. Plan it. Am I going to have enough room for this? Very important. Um, Now, if these are each 3 units long, that could be centimeters, that could be inches, whatever it is. That means that it's going to be, well, 3 units long on here. As you can see, I'll actually even like enhance these dots here a little bit. Make that even bigger. So these are the dots in the actual paper here. Now, when I say 3 units long, there's 4 dots, right? But this is a unit. Here's the second unit. Here's the third unit. It's gone 3 units long, even though it's 4 dots, and it's gone at an angle. So again, I start with angle A, right? I start at something that's closest to you, the bottom corner closest to you. Now, in this case, I've gone up 3 units. Sorry, they've gone up in 3 units. Now, again, I want to show depth. It's a 30-degree angle both ways. And you just keep on doing that. Again, you want to kind of plan it out. This is where loosely can be helpful is, you could think about like, okay, what is this going to actually look like if you're stuck on those 30-degree angles here? Sure, so again, it's taking a sketch and it's making it realistic. These are all scaled properly. This is 3 units. This is 3 units. This is 3 units. This is 30 degrees. This is 30 degrees. So it's an accurate way. It is the closest that you, a human, can get to a computer generated image in a sense. Um, so for an example here, if I give you this drawing here, the front wall is 18 feet long. This one here, and I want to find wall X here, wall Y here, and wall Z here, as well as the height of the room. So I'm finding 4 things. And I only have the information here, which is that this wall here is 18 feet. So let's think about this. If this is 18 feet, how many units is this? It's 1, 2, 3, 4, 5, 6, 7, 8, 9 units. So if I have 18 feet and there are 9 units, 18 feet divided by 9 units, it's 2 feet per unit, right? And again, I am counting the units, not the dots, not the dots. You're counting the space in between. It's almost like a histogram in a sense. So if that's the case, oh, well, that's pretty simple. If I know that each of these units then is 2 centimeter or 2 feet, sorry, all I need to then do is, well, just count, right? So X here, X I can see is 2 feet. There's only 1 unit. For Y, there's 1, 2, 3, 4, 5. There's 5 units. 5 times 2 is 10. 10 feet. For the height, there is 1, 2, 3, 4 units. So that means that the H height is 4 times 2 is 8 feet. And then finally for Z, we have 1, 2, 3, 4, 5, 6, 7, 8. 8 times 2 is 16 feet. So that's what I kind of mean by scale. Like this is all I know exactly how big this room is because this is all done properly. It's drawn properly to a scale. Um, okay. So for this one here, so sorry, reading it, not too difficult. Drawing it, that's the hard part. Now, I want to draw this shape here as an isometric drawn, so on this paper, at a scale of 1 to 20. Right? So as a scale to 1 to 20, again, model to original. This is my model. This is my original. Okay. So what that basically means is that the original, this is 20 times bigger. So 20 would turn to 1 unit long. Here's a unit long. That's what that's going to look like. 60 would turn to 3 units long, right? Because 60 divided by 20 gives me 3. This would turn to 5. This would turn to 2. This would turn to 3. And now you have everything that there is to measure. Now you might be noticing there's nothing here. I don't know how tall this is. You could figure it out probably if you wanted. Like, you know that this line here is 40 centimeters, right? All of it's 100 minus the 60. You know that this one thing here is 20, but you don't need to know this because you just connect the dots, right? And I'm using this indicated edge as my starting line. So again, start at a corner, plan it out. I need to start and I need to have some space to the right. I need to have some space to the right. I need to have some space to the left, and I need to go up. So maybe starting like right here isn't a terrible idea, right? I have space to move right. I have space to move up. I have space to move left. So I'm going to use my line tool here. And I'm actually going to zoom out a little bit, just so you guys can see properly. Here we go. There we go. Okay. Good enough. So I'm going to start with this line here. Now it wants us to go So this is 20. It means I go up 1, right? 1 unit. Now at a 30-degree angle, I need to go up 3 units. So 1, 2, and 3. 1, 2, 3. Connect those. Now, I don't know how big this is, right? I don't know. So I'm not going to do that. Instead, I'm going to move left 5 units. And again, think about the point. I'm starting at this point here, the very bottom right, very bottom right. Now, I can't just go left. Doesn't work that way. So how am I going to do it? Well, remember, I have to go 30-degree angle. So if this is 10 of these, I need to go a 1 to 20. I need to go 5 units here. So I'm going to go 1, 2, 3, 4, 5 units. Um, excuse me. So, and then I'm going to do it the exact same way here. So now I can go pure up by 2 units, right? So now I'm right here. Then I need to go diagonal here, 3 units. So 1, 2, 3. Same thing. This is going to go 3 units here. Oop, that's not very good. There we go. Another 3 units here. Can connect these. And that gets connected there. So that's what it's going to actually end up looking like here. And again, I know it's all scale accurate and stuff. So, but kind of tricky. Like you might be struggling to follow along with this. You might be struggling with it. That's okay. It takes time. It takes practice. So don't worry about that. But again, you should now be able to actually like measure this. If I could rotate this, I could, and it should be the correct amount of centimeters. Oops, away. Yeah, I can't. Very annoying. Be very nice if I could. Hmm. Okay, so let's go to this one here. So now I want to actually draw this, an isometric image of the storage unit using the indicated edge, this one, red, this one, as my starting point. So again, one thing to note here, it doesn't tell me an actual scale. So I need to pick a scale here. Now I need to try and find a number that's going to work well for all of these. I need to try and find what's called a common denominator. So what's a number? I could go up by tens, for example. Tens works. 20 does not work. 30 works. So you could do either way. Now, if I go up by tens, I need 30 dots. I don't have 30 dots. So the tens, so I know tens works. I know 30s works. 10 doesn't work though when I actually think about the space. Um, is there anything in between there? 15? 15 could maybe work. Yeah. Yeah, yeah. 15 does work, but it's then I need to go up by 20 units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, it does not. So 15 doesn't work. So I have to do 30. So I have to do a 1 to 30 ratio here, which means now this is 10 units. This is 3 units. This is 9 units. This is 4 units. All right. So now let's also think about this. How am I going to draw this? So I'm starting at this point here, right? I know I need to move to the right. I need to move up. I'll probably need to move down a little bit to show a little bit of height. So somewhere around right here is probably a good starting point, right? Somewhere near the bottom left corner, but still gives me some space. So we're going to start with this line here. I'm going to go all 10 units of it. So let's start right here. Sure. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 units right there. So I've done that whole line. So now let's keep going this way. Now remember, I need to go 9 units. This is not how you do it, though. I need to go 9 units at a 30-degree angle. Now that means I either go this way, I'm facing, or it's going to face this way, or I'm going to have it where it goes this. Oops, where it faces this way, which is the easier option in this case. So I'm going to go up by 9 units. 1, 2, 3, 4, 5, 6, 7, 8, 9 units. Right? And I'm actually going to do this, which is kind of an easy way to keep organized a little bit. So now I need to go up by 3 units. And what I mean up here, and not at the same angle. Again, I've had it where it's faced in a different way. So up by 3. And then we're going to do the same thing here to gives it some depth. Go. And same thing, I got to go up by 10 units. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Same thing, going to go up 10 of these. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. Oops, that's not right. 2. So 2, 3, 4, 5, 6, 7, 8, 9, 10. So at this point, I've done this, I've done this, I've done this, I've done that, I've done that, I've done this, because there's a little thing there, right? So I'm almost done. I still got a couple more lines to do though. So I'm going to do this back line here, which is just connecting these two, right? So at a certain point, it just becomes finishing the drawing. I could measure this, but at a certain point, it's really just finishing the drawing. What else is missing? Just from eyeballing it, this thing, right? Which is done up 4 units up. So 1, 2, 3, 4. And then it just goes across at an angle. Now, does it connect here? No, that's the back. It connects at the front here. Am I done? No, because there's technically this little line here, right? So I'm also going to connect these ones. Now I am, in fact, done. In fact, I'm going to make this a little dashed line if I can. No, I can't. No, I cannot. Okay. Well, that sucks. Okay. That's what it looks like then. Can't I? I swear to God I could. I'm not insane, am I? Aha! Oh, yes, I can. It's just not going to be very like straight. Oh, yes, I can. Okay. Perfect. Cool. So I've done my little like line here. So this is what the actual complete drawing looks like. Again, you're noticing here it's an entirely different angle than the one you were given. You cannot go just pure left to right. It doesn't work that way. You cannot. Again, you could do it this way. You could have it where it's I could have it where it's oh wait, what? Can I flip it? Is that a thing that'll let me do? No, it doesn't. Okay. Nope, doesn't let me flip it. I don't think. Nope. Either way, so you could do it a couple different ways, but this is one way to do it. This is hard. Okay, if you're struggling with this, don't worry. It. Oh, sorry. Also, it's a 1 to 30 ratio here. Okay. So isometric drawing is pretty hard. Now let's shift to something we call a perspective drawing. This adds 3D to it essentially. So this is where we try to represent objects as we actually see them. And we have what we call a horizon line. So again, perspective drawing, this will make so much sense once you see it. Okay. If you're confused right now, I promise it'll click really well. So it uses the ideas that parallel lines appear to intersect at a point at the horizon, which is what we call a vanishing point. A lot of terms here. This is going to simplify the second we draw this. I promise to you. Basically, we're taking the 3D object, we're making it 2D, but we're still adding that depth to it. So for example, if I'm going to give you this vanishing, I want to draw a horizon line and a vanishing point here. How am I supposed to do that? Now they give you an example here, as you can see. But all you're basically doing is taking all your lines and connecting it to that point. That's all I'm doing here. And then I would just erase this point here, basically, would be what ends up happening. Now, I can't erase the actual text here, but that's what would happen. But I can do this. Oops. So what I did was I connect to the horizon line. And then I need to cut off the shape. What does that mean? Cut off the shape. Well, doing this. Taking a point, going straight left to right. It's not letting me. Straight left to right, and then up to down. And I'm just going to erase the rest of that stuff there then. Now all of a sudden, so again, I've turned a 2D object into a 3D object. Again, that's what it looks like here. So there's some kind of step by step here, but that's what ends up happening. So I want you guys to do this here. So quickly draw your two perspective drawings of here. Try and finish it. Give you 3 seconds. 2, 1. So you should have something like this here at this point. This one's kind of tricky. But again, should be like erasing it here. Should be erasing that. All right. Up here. There's that there. Same thing. So kind of something like that. This one's really hard. Okay. So A is really hard. B, a lot more straightforward. And this is done intentionally for a reason. Because look at where A is. It is technically inside this rectangle. B, the point is outside the rectangle. Having it outside helps a lot. It makes it so much easier. So put your vanishing point outside your shape. It makes that adding that 3D element to it incredibly, incredibly simpler. So draw a perspective drawn of this one here. So again, same thing. Pause video, try and do it. 3, 2, 1. Now, you might be having trouble with question 5 here, and there's a reason for that, is because you also need to be including these invisible points here. And you notice now I've put these dash. So I've taken, this corner, and this corner, which you normally can't see, and I brought it all to that vanishing point. And now is when I can connect each of those. So this one here, for example, would be pure vertical, right? Right? Vertical. Then it would go across horizontal to our from a visible line to our other visible line. Then from our visible line to our not visible one, it just goes just down a little bit. It's not that much there. And then we just move to the right. Now, these lines are so close that I'm not going to bother with this point. So again, I erase these now. Or something like that. Sure. Now, all of a sudden, it becomes a little bit more visible here, right? Now, I can, of course, erase these lines inside. These little invisible ones. I don't fully actually, well, this one, sorry. This one here is a visible line. This one's visible. But this one here is not. So you can do something like that. It depends on the draw, and sometimes it's better to leave those invisible lines there or not. Like, for example, if I were to go to the, oh my gosh, it's such a tight margin. Screw it, it's fine, it's good. But if I were to go something like here, for example, having these visible points here probably could have been a good thing. So yeah, just something to kind of note here. All right. I mean, this one, you guys at this point, should realistically be able to do, but I don't care that much about this. You can skip this if you want. Do it if you're struggling with it. Ask for help, but don't worry too much about it. Actually, do it, but I'm not going to do it on screen here. All right. So at this point, I recommend you actually pause the video, stop it, work on some of this stuff, work on some of the practice questions here as best you can, and then go into the exploded diagram here either later or next day or something. So I'm actually stopping this video. This is part 1, and we're going to resume it with part 2.